Okay. Hello, everybody, and welcome to today's device management interface call. Thanks for joining. As usual, the call is public and recorded and will be shared live on YouTube. So the first topics I wanted to discuss today were a couple of JIRAs that were created based on some PM data requirements coming from the operators. These two are the OLT PON transceiver data and the OLT NNI transceiver data information. These two are not retrievable by some of these elements, especially the transmission power, the transceiver temperature, transceiver voltage, and bias, and the same for the NNI port, are not retrievable via any other mean than a platform API, which is what can be used in our device management interface. So I just wanted to bring up this requirement from the operators and make sure that it's been acknowledged. I'm not sure we have to do something right away, but it would be good to have it at some point. Any thoughts?
So, Andre, just to understand the JIRA that you brought up, it has some subtasks. Just go back, and they're in progress.
Yes, so these are for the receiving power. These can be captured by BAL. That receiving power can be captured by BAL. I'm not sure about the transmission power, that we have to check. But for example, the temperature, the voltage, the bias cannot really be captured.
Okay. So so maybe Holger could help us. So can the RX power be captured, Holger, over the TM?
I'm sorry, I have to check offline. I don't know.
Okay.
I just, again, as I said, it's not like that we have to deal with them right now, but I just wanted to bring them up to the team to make sure that we are aware of these and that we are checking. So if you guys can check what are our possibilities to take care of these, it would be really nice. Okay. So let's maybe, go ahead. Hold on.
Andrea, like on the temperature, voltage, and bias current, I think we can use the OLP APIs, and we can fetch the same for a given transceiver module, and also the TX bar. But for the RX bar, it is to be measured exactly when a particular ONU is given the upstream transmission slot to emit. Exactly at that time, we have to capture the recording.
Yes. So for that, so again, as I said, the receiving power, it's okay. We're dealing with that in BAL, at least on the OpenOLT agent. And I believe that at some point also the Adtran guys will implement it via Volta, because we don't have the capability to use the BAL APIs via the device management interface implementation. You guys might want to implement it, but for now, the receiving power, I'm not concerned about it. The transmission power, temperature, voltage, model, and things like that are the ones that we need to fetch through the ONLP APIs, which is perfectly valuable. It's just, I don't particularly care how we fetch it. It's just that we need to fetch it and expose it. So let's maybe check on offline if these are doable, and then get back on this the next meeting, and also if it's possible and doable for you guys at Adtran, Holger.
Yeah, we do. Yeah.
Okay, and then if we agree that these are elements that we can get, which I believe we do, we need to extend of the APIs for them to be actually fetched by the device management, unless we already have all of this, but I have to check.
So, Andrea, one question here. So, how do I put it? So, if something can be retrieved via BAL,
Yes,
can't we have it in the DMI interface?
we can. I'm not saying we can't.
Okay.
But to simplify the life, for now we have. I mean, it's an implementation detail, as we have said in the past. Volta will retrieve it if you're interested, because it has already a direct link to BAL, and it was easy for us to retrieve it over there. But nothing prevents us to use as well the BAL in an implementation of the OpenOLT manager, Open Device Manager, call it Open Device Manager, sorry, and just retrieve that data.
Okay.
If you say Volta can retrieve it via BAL, you mean via the OpenOLT adapter?
Yes, via the OpenOLT adapter. So for you guys, it would have to
Yeah.
be a combination of the Adtran OLT adapter plus some API that you guys have, which I think you do, or you just don't support that.
Yeah. Okay. Yeah. I think we don't use BAL on our device, so that's why I'm asking. But
Absolutely, yeah, you can do it. I mean, there must be something you can do.
yeah, sure. We're using Broadcom SDK directly, but it's okay.
Okay, perfect. Okay, let's reassess next time on these. So next up, I want to bring up a couple of discussion points that were raised by Holger in relation to some of the changes that we made according to for the events upon restart of the device, and also of the distinction between reboot versus loss of communication. So the first one was that during our past sessions, we said that on device reboot, it would be up to NEM to actually purge the alarms that it has within itself for those devices that rebooted, so that whenever the device comes back up, it will resend all the alarms that are active, and NEM will just receive those alarms that are active. Holger made the point that this might not be the best solution for an off device manager, meaning not a device manager that sits on the device itself, but something that sits in the cloud and talks to the device with a different API, which is what Adtran has. In their case, what they're doing, and Holger, correct me if I'm wrong, is that they are computing the diff in the device manager of the active versus not active alarms, and sending the cleared alarms for those alarms that were actually cleared during the reboot scenario, during the reboot phase. So that's the problem statement. Have I misunderstood something?
No, that's correct, totally correct. And we are also generating new alarms in case alarms have happened. Sure.
Okay.
Which is more the case for the loss of communication case, perhaps.
Okay, so what happens is that at the moment, these two actually do collide, because what Adtran is reporting is a diff, because they can store the alarms within the device manager. What our device-based implementation instead is reporting is all the alarms that are active, and there's no diff. So the NEM has to make the diff. So the idea is that we should be able to support both scenarios. A scenario where the device or the device manager is a little bit more intelligent and has more knowledge about the state and stored the alarms, but also a case where we don't store the alarms and NEM has to do some more processing. So the proposal was that we could have a specific event, which is called Purge Alarms, which can be thrown when the device reboots. If the device reboots and it needs them to purge the alarms because it will resend them all and send them all the active ones and all of that, it will send this event as well. If not, we just proceed assuming that we will receive cleared events for the alarms that were active, and for those that we don't receive cleared events, that is the case that the alarm is still active. Now, this is a proposed solution, but I would like to hear everybody's thoughts on it. If it makes any sense at all.
So on a reboot, there'd be two alarms or two events, one that says I've rebooted and one that says potentially, please purge your list because you're going to get all new alarms.
Yes, and the idea is actually you could, by decoupling these two events, if some scenario within the manager or within the device yields a situation where we have some inconsistent state and we would like them to purge alarms at any given point, maybe not even after a reboot, we actually could use that purge alarms event for doing so. Otherwise, the other way of doing it would be including a flag in the reboot event, but I think this is cleaner. And again, as I said, allows for other scenarios to use that event, this event.
Yeah, I mean, it makes sense. I'm not sure what the name purge, but other than that, the intent seems reasonable.
We could call it clear all alarms or something like that.
Yeah, I'm trying to figure out trying to think what it really means, right? It really means the device is going to resend the alarms, right?
Yes, yes, that is mandatory.
So that's kind of, the minute you say clear or purge, you're implying an action on the other side, where what you're really saying is, hey, I'm about to resend everything. That's why
yeah,
but the name, right?
Yeah, but the action that needs to be taken by NEM is to delete in itself everything.
It doesn't have to, right? I mean, that's the point, right? The alarm is saying, the alarm should be named based on what it's doing. What it's doing is it's about to resend all the alarms. So it's not about when you say clear or purge, it's about what the other side, the receiver, is doing, not what the sender's doing. Just suggesting the alarm name should be based on what the sender's doing. It's a trivial matter in the long run, but
Okay. I'm fine with the resending alarms. The idea is really that NEM should prepare itself. What does NEM do? Up to them.
Yes.
And in principle, I think it would be good if we could, as part of the event, there could be a UUID for the device, or there could be like no UUID, which would mean it's meant for all devices. Like cases where you, I don't know, reinstall a device manager, and the device manager might lose its history in this process. Then instead of sending this for every device, you just send it once, and NEM should delete the state for all devices, or be prepared to get new alarms.
That's fine by me.
Is it a one or all, or is it a one sum or all?
That's why I put there. That's why I put there a repeated UUID, David. because it could be.
Okay, I'm not looking at the screen right now. Sorry.
Yeah, it's fine. I would say a repeated UUID. If it's empty, just do it for all. If it's full, do it for the devices for which you're getting the UUID.
So I think as of today, the events that we have, they are only on a per device basis, I think. So are we planning to change that structure altogether?
So Amit, what you're saying is that we have a per device event. So to support what Holger is mentioning, is the DM should send this event for each device.
As in, yeah, I think what Holger is saying that we keep the structure the same, but send one with an empty UUID. I think that's what, at least that's what I'm implying.
Mm-hmm.
Right. But give me a second. I'm also just looking into the event structure.
Yep.
Event metadata. Yeah. So the event metadata, event ID has one UUID.
Mm-hmm.
So, so wouldn't it be just cleaner if we just kept it the same way? So if we are trying to clear the alarm of, say, I don't know, 50 OLTs, yeah, we send it in a loop.
So if we keep the way it is with just a single UUID field, if that's empty, then everything's going to be reset. If it's got a value just for that one device, is there ever really a use case where, I want to do 30 of them, not the other 30?
Probably not.
And I would think leave it the way it is and don't worry about a repeated UUID, particularly if the rest of the system is already based on single device event or single event per device.
So what we're saying is that we should send all the alarms for each device for which we want to resend the alarms.
Unless you want to do it for everything. So it's a one or all option.
Yeah, agreed.
So what I was thinking was that I don't know how common this use case is of firing, resending alarms for all the devices that the DM is handling. So maybe just keeping it one event per device would be simpler. The reason why I'm also thinking about that is, say, for example, if you send with an empty device ID, UUID, most probably NEM is going to call get managed devices to find out actually which are the devices the DM is managing. So effectively, the DM anyways has to return back all the UUIDs.
And what is the issue there? I missed the point.
What I'm saying is that there's no issue in that. What I'm saying is that what we're trying to save here is sending a blank ID saying that, okay, I mean all the devices, but the name is going to come back and ask the DM, okay, give me the list of devices. Right. So what we're trying to save is actually not a saving, right? That's what I'm trying to say.
So how?
Well, it depends, right?
So how?
One event. It's one event and one round trip API call for 64 devices versus 64 events. So there's a savings there.
Yes, and that's why I started off saying that I don't know how common this use case is. So if it's not a very common use case, then it doesn't really matter, right, to optimize that.
That's a fair point. I don't know how common it is either.
I mean, for us, it's just a documentation point, no?
No, right? Because in the NEM, you have to have different handling for this, right? Saying that, okay, when I get this event, if the UUID is empty, then I need to go into doing this processing, find all the devices, and for each of them, do this, right? It's not complex. It's just that we will have to write differentiated code versus
I see what you mean.
always done for a single device.
Yeah, yeah.
Right? The implementation within the DM would be firing the same thing in a loop. Right? The only thing is, what I'm suggesting is that because I don't see that this would be happening too often.
I know it's not.
Let's say a head end whatever head end resets, Manhattan resets. Is it going to happen at that point? If the Manhattan experiences a power outage and I've got a bulk reboot, am I going to get these events for every device that's covered by that bulk reboot?
Sorry, David, I'm not able to make out exactly what you're saying. The voice is not very clear, at least for me. Andrea, are you able to make out what exactly you have
No, I missed David's sentence as well.
So I guess the question was. Go ahead. Sorry.
If there's when would this event be sent? Right? Would a bulk reboot or a power outage perhaps cause this to be called for every device? So it may not happen often, but it may be that when it does happen, it happens to a lot of things. So there's, it's an elephant.
So it would not happen for our device manager. So for our device manager, it will only happen if the persistency gets lost. So if the database crashes or something, you have to reinstall it, and the device manager comes up with a total empty database, then we don't have any history anymore. And that's it. In a power outage case, you wouldn't notice anything. You would just sync to the state of the device and then send new or alarms or clear alarms, whatever is needed. But we wouldn't be, we wouldn't be sending this event anyhow, never. This is only for the, it's only more meant for the device manager on the hardware. This is sending the event. And it would be sending the event in a power outage case, yes. Because if all OLTs have a power outage, then you would be seeing one event for each OLT.
So if the database gets corrupt, then this event is going to be sent for every device in the that
only
you
once.
need to manage.
No, in this case, if we do not know the devices anymore because the database is not there anymore, then we will just send one event to them telling them that please ignore everything you had before.
Unless we took the suggestion that instead of doing that, we had one event per device. So
but in this case, the device manager cannot send the device one event per device because it doesn't know the devices anymore.
Well, that's a good question. So let's say my database is corrupt and I'm restarting or my device manager in an existing system. So NEM knows about 500 devices. The device manager comes up with an empty database, so it knows about nothing. Mm-hmm. It has no way to tell NEM, hey, here's all the devices you have to be reset, unless there's I just added an event to let NEM know as the devices are added back into the device manager to treat it as a new entry. Right? When a device is added to the device manager, I assume there's a new device event sent up to NEM.
I know.
There isn't?
No, there's no event.
How does NEM become aware of a new device?
The RPC gets a response. So you do a start managing device and you will get a response.
So NEM has to add the device.
Yes.
So if someone added a device to the device manager via some other mechanism, call it a CLI, NEM will never know about the device.
Yeah, theoretically, I mean, there is no CLI for the device manager, so it's only this gRPC interface.
Right. So someone could write a CLI, or I guess I'm surprised.
I mean, there could be another NEM, a second NEM, which would add devices, and then they would run out of sync.
Yeah, I guess it caught me a little off guard. I was surprised there's not a new device event or the new device under management event, so that anybody listening can say, now I have a device. Because that would be the in the case where the database is corrupt, and then a new device is added somehow. That's how northbound systems would be notified.
Yeah, David, but in this case, the device discovery is done by the device manager. It's not expected to be done by the device manager.
So there's been a common issue in network element management forever, that everybody assumes that all operations happen through some single system, and then they don't, and things go wrong. It's not safe to assume that there's a workflow where the person that adds the device to the device management system is also the only one who knows about it. It's a risk.
I mean, nothing prevents us in adding a start managing device event. I mean, right now we have the response to the RPC, and it's fairly trivial to just fire an event on Kafka. That should be no issue.
Yeah, because the thing who adds it may not be the thing that manages it, in some sense.
I'm missing the point here.
Well, that same event that says, hey, there's a new device under management, is also the indication to any northbound system to reset any data around that device. So if I get a new device under management with a UUID or some unique identifier, and I already have that device in my system associated with data, when I get a new device under management event, it's clear to me that I need to do something about that, because I've already got it in my record. NEM would already have it as a record, but it's also getting an indication from the device manager that it's a new device. So that would be the indication to NEM to clear all data around it. That's where it's relevant.
So at least the way it is being used right now, at least in case of A4, is that the discovery of the device is the headache of somebody else, right? Which is, part of the NEM, but nothing to do with the DMI interface. And once the device is discovered and liked by the NEM, whatever logic it wants to apply on that, then it, using the DMI interface, it says, okay, I want to manage this device. So
using the DMI interface, someone calls a gRPC request, says, I want to manage device X.
Correct.
Right?
Yes.
That's fine, but is it a safe assumption to assume that's like a registration of the device with DMI, right? That's what it is. That gRPC call basically says, hey, DMI, here's a device, put it under management. Right? The event stream that's not a streaming gRPC call that's going to receive all events from that device at that point. It's just a single request reply.
Yes.
That's streaming.
So at that point, right? So there's no guarantee that the person who sends that request is also the same person, is the only person or the only entity that is involved in management. So I could have a periodic discovery that calls this API, and that's it, right? And it might be something else that is going to be interested when a device actually comes under management. All I'm suggesting really is if the device manager sends a new device under management event, that is also an indication to any northbound system that if they have any old data associated with that device, it's time to clear it. Right? So in the case of needing to clear the events, it really is, hey, there's kind of a new device under management event would indicate that. And that would be the use case when the DMI's persistence is completely gone and essentially restarting from scratch. Right? Or if we don't do that, the other use case was why would I ever need to send a reset all data? Because the only use case I've heard that I would ever send that from the DMI is my DMI's database is corrupt. And at that point, all the devices have to be re-added. And if we're going to assume NEMS is the only one that's adding them, well, it knows as it adds it, it should clear any data with it because the DMI is gone.
Yeah, but the other use case is the DM running on the device. It will send this event.
Right, but then it's a single event. For a single device, not for all devices.
Yeah, a single device event, yeah. Mm-hmm.
So the use case for sending clear everything is the DMI's brain is gone and you're gonna have to re-add every device anyway. And so in that case, whoever's adding the device already knows that it has to clear the data. And if we're gonna assume it's NEM, then NEM already knows it has to clear all the data associated with everything as it adds each device. So I guess the argument is we don't need to clear all.
If we introduce a new event, like new device discovered or whatever.
Well, even if you don't introduce that new event, the NEM is going to know, oh, I'm about to add this device, I have to clear the data associated with it. Right? Because the DMI has no devices, its brain is completely gone. Something has to add each and every device back. And as it adds each and every device back, if that is the NEM, it knows it has to clear the data at the same time.
Yeah, I guess you're right.
So while I'm kind of still in support of, we should have a new device under management event. I think for the use cases stated, if we assume NEM's the only participant, we don't have to. And we only need, back to, I can't remember who made the suggestion, we only really need a reset for a single device. It's never going to be all.
Quick question: could there be a case where we actually need that started managing device event in case like there are replicas of NEM? Maybe. Not sure.
From the network management perspective, it's always been a little risky, assuming you're the only entity calling APIs on device, right? In traditional network management, where an element has a CLI even on the device itself, even if you have the most great, most wonderful EMS system, someone's going to go to the CLI. And so if events aren't, if it's not assumed that you have multiple entities managing your device, you can get in trouble, and it has happened many times. So again, I'm in favor of sending events like that, but in the use cases described today, with the assumption NEM is the only participant, you can get what, you don't have to do that. If we have multiple NEMs, particularly if we have multiple NEMs kind of in an HA scenario, presumably they're sharing data somehow. They're not going to wait for they're not going to necessarily synchronize through events from the device. They're going to have another synchronization.
So, Andrea, on the question that you're bringing up, right? I don't have a problem with that. Yes, we can add it, but I prefer to do it once we have concrete use cases for that, because we could implement it, but no user for that, right, as of today.
Agreed. Okay, so the idea is that we're gonna create a resending alarm event that needs to be triggered for each device, and that will tell them that it will need to purge the alarms it has in itself and just proceed, as all new alarms will be sent from the device or the device manager for that device particularly.
Yeah, so if I were to try to summarize it, my understanding, when NEM receives the resending alarms, it will assume that whatever are the open alarms or the raised alarms for that device have become meaningless. And it assumes that whatever are the relevant alarms from that point of time onwards are going to be resent. That's correct, right?
Yeah.
That's my understanding too. It does mean that, let's say I had alarm X set, NEM knows alarm X is set. It's going to be resent from the device. So NEM has to be intelligent enough to say, hey, X was set, but I'm going to get I re-got X again. I don't necessarily want to take a repeated action based on that alarm. Does that make sense? Because I've already processed it once.
Yes. Yes. So say there were 3 alarms, X, Y, Z, right? And then NEM gets a resending alarm event. And after that, it might get X and Z only. Why not? Right? Because maybe during this time, the Y got anyways cleared off.
Right. And so the problem is NEM doesn't necessarily have all the knowledge to know that one of them got cleared, right? Because unless we get an explicit cleared event, are we going to send events for everything that's cleared? We're going to send a clear event. Or everything that's not an alarm, we're going to send a not-alarm event. Because how does NEM know that it's been cleared versus he just hasn't received the sets that it's been set yet?
No, so NEM doesn't know that, right? But what NEM is going to do is, as soon as it gets resending alarms, it is going to wipe out the state for XYZ. It doesn't care about them anymore. And whatever it gets is what it uses. Yeah.
Let's use your example. X, Y, Z are set.
Yeah.
Right? And NEM has done 3 actions. He's done action X, action Y, and action Z, which are the actions he does when the alarms are set.
Yep.
NEM gets a reset event. Then X and Y are sent again. And NEM has to be smart enough that X, I've already done the action for X, and I've already done the action for Y, so I don't want to redo it. How does he know to do the clear Z action? How does he know he just hasn't received the Z alarm yet versus it's been cleared and he needs to do the cleared action?
Yeah, I think that's a good question that needs to be looked into. Right now, at least we have not looked into taking specific actions, automated actions, to be more precise. So yes, when automated actions are being taken, I think, yeah, this needs to be looked into.
So right. So another common scenario in this case, when they have to, northbound system has to reevaluate what alarms, they essentially get all the alarm states. It's not that they wait events for new alarms. They reconnected to the device. They go out and query and say, give me your complete alarm set. And by the way, continue to give me notifications after it. and then they sync on a complete alarm set. So the northbound system is going to have to do a diff between what I have and what's on the device, and then take appropriate action based on that diff. So I'm not convinced that this just resend set alarms is going to be enough. NEM's going to have to say, look, NEM has to be given an indication that the alarm state is out of sync, or whatever you want to call it. And then NEM's going to have to query the complete alarm state of the device and do a diff between what it has and what the device gives it. That's the only way NEM can correct its state.
I mean, this is actually what we're doing in the device manager. So we have an alarm database on the device, and we just get the state of the alarm database, and then we see which events are still there or are not there anymore. So it sounds like it would be better. It would be better to implement. So instead of resending alarms, it would be better to not send alarms again, but provide an option to query the list of active alarms.
Right. An event that basically says the northbound system, things have changed. Go redo your alarm state.
Hold on. The precise reason why this event, we started discussing this event, was that there are cases where the device does need to resend the alarms, and it will resend them. And it's not gonna just wait for a query about these alarms. So if you're saying that NEM could ignore those alarms that are being sent and just go ahead and query them, sure, but they're gonna get sent.
I'm saying a resend of an alarm isn't enough to resync a database, an alarm database, with reality. Right? It's not enough. The northbound system needs to understand that the northbound system needs to be able to query the complete alarm database and diff that with what it has, so it knows what alarms are actually set and cleared and can take the appropriate action.
So I think, Andrea, I think we have come a full circle, right? I think one of the reasons why this clear and all was started off, or we moved into this direction, was because we didn't want to store the alarms in the device, right? Because when we rebooted, we were not able to figure out what those alarms are. And that's why we said, okay, we will send the alarms fresh. But if we have to support a feature where the NEM could query the active alarms, that means they have to be stored on the device.
Not well. That is precisely what I don't want. We need to support both cases. So no. And if you lose something because the device is not capable of storing the alarms, and a NEM queries and sees only 5 alarms because those are the ones that got they were there after the reboot, I'm fine with that.
I just don't know how, without being able to query the alarm, NEM is able to tell that the alarm went from set to unset, and NEM has to act on the clear event.
The assumption is, if you get this event that we're talking about, the assumption is that nothing else is valid on what you had before, and whatever is valid is the only thing that gets sent out to the device after you get this event.
How do I know when the device is done sending all the new, or resending all the events?
You're not going to get resend events. You're going to get all new events. You assume that it's all new events.
So how do I know, going back to the use case, I have event X, Y, and Z, alarm X, Y, and Z. I get the resend alarm event, or whatever it is, and I get X and Y, but how do I know that Z is not going to be sent ever, or hasn't been sent yet? Do I just time out and expect to get all the new events within a 5-minute time, and if not, I clear everything else?
No. The idea is that you're just gonna go ahead and preemptively clear all the alarms. So whatever you had in your
But I
state,
can't.
why
I
not?
take an action when an alarm's cleared, perhaps. What happens if I have an action queued off, triggered off, an alarm clear? I have to know that alarm's been cleared. I can't just assume it.
If we don't store the alarms on the device, that's the assumption you have to make.
Okay, so if I assume that, let's go back to the use case, X, Y, and Z. I get the event that says I'm going to resend alarms. I'm going to do a clear action on X, Y, and Z, which may have some other consequences. And then when I get X, Y, and Z back, do a set action on each of those, or X and Y. There's something missing, right? The system may do some incorrect behavior because you're making an assumption.
Guys,
if it's just a display on a window, it's probably not a big deal, right? But the problem is actions are taken off that display on a window.
So really, there is no way we can store the alarms on the device. There's like, if it reboots, it reboots. You have to store them to disk. It's like a pain, completely a pain. So you cannot do it. So we have to find a way to tell them, do your best.
No, but Andrea, so then I think we need to also understand from the functionality perspective, right? Because we are saying that it's not possible to store the alarms on the device, and we don't want to also have another component, right? Which is, for example, with the Atron model, right? A component which is closely tracking each device, right?
Yep.
And we want to push the responsibility to NEM, but I think we are seeing a problem, as David is bringing up, when we have something like an automated action, which I don't really know how exactly that works. But if once that kind of a feature comes in, I think we have some functional blockages, right? We really can't solve the problem without having the complete information, right? So maybe we have to look into places which are lower in the system, right? Either on the box, or we have to have an intermediate guy which is constantly talking to the device.
I'm still not convinced. I think that there are ways we can just say, this is not on the device anymore. Give it maybe a 5-minute window. Okay, maybe it's a timeout. Maybe you give it a 5-minute window. If you don't receive the alarm back in that 5 minutes, you consider it cleared. I don't see it as a big deal. Maybe it's me. I don't know.
Anything that a timeout is as bad as sleep, right? It's a heuristic guess, right? Does the device not even keep the alarm state in memory?
That's the assumption, that it's going to be kept in memory. But if it's rebooted, okay, you're going to lose that memory.
So how does it know when to send the alarms again? It's
whenever they are fired again from the platform API.
Oh, okay. Does the platform API have the persistent alarm state or alarm database?
Not that I know of. But my assumption is that if the temperature goes higher than a threshold, you're gonna get an alarm, even if you got it before, like a periodic alarm.
So maybe I would also want to hear from Chandra. So Chandra, what exactly is the problem in persisting the alarm? So as I understand, you're going to anyways have them stored in the memory. So the only question is persisting them across a reboot, right?
Yes, Amit. Basically, whenever alarm is rising, say OLT high temperature alarm, we need to have it in the memory, so that next iteration we see that when the temperature is normal, you have to clear it. But now coming to persisting in the disk, we had like discussion earlier with the pros and cons. Problem would be if at all we have to persist in the disk after device comes back, when it scans through all its hardware inventory and components, it has to compare with what it has in the memory, sorry, what it has in the disk, and clear whatever is not required and erase whatever is newly detected. So that complexity we want to avoid in the device implementation from the last discussion, Amit.
Yeah, okay. So I get that. But what we are seeing now is that when we are trying to push the problem into the upper layers, maybe we are losing information because of which some use cases can be solved easily.
And the latest occurrence of the alarm is always better, so that the vendors also can correlate with the system logs and see what was the exact reason. If you have the earlier reported alarm in the northbound system, how do you really correlate with the actual device logs? Latest is always better is what I think.
So, see, okay, if you take away the reboot, right, the logic is that whenever you get a trigger, you either raise an alarm or you clear an alarm, right? You get a trigger from the platform.
Right.
Yeah.
Yeah. So in case of a reboot, instead of getting a trigger from the platform, the reboot itself is a trigger where you evaluate all the open alarms. Right? It's just the trigger, the direction of the trigger changes. But then the behavior of the system or the box remains the same, right?
Agree, Amit. Basically, we have to call all those platform APIs to assure if the alarm is still active or condition no longer is detected. Yeah,
Correct.
during device initialization, we have to run all those platform APIs to conclude what to read, what to delete.
Yes, so only the ones that are no longer alive, you need to clear them. The ones that are still open, they are still open. You don't have to do anything to them. So anyways, I am not suggesting that you need to do it, but maybe we should also think in that direction to see if that could help in solving some of the functional problems that could come up in the higher layers.
I mean, it definitely would, because that would make the device, the on the device software effectively equivalent to what, for example, Holger has in their device manager, which is that wherever the logic is, that logic does a diff. We can make that assumption. It's harder on the device, and it needs to find a way to persist information on to disk. Again, it's doable. It's just a harder implementation, I guess. Which we decided not to go because we expected it would be easier to do it into NEM. Maybe we found out that it's not so easy to do it into NEM, so we can do it there. Sure.
Yeah, I think we should just go back and check on this, right? If as in which is like the more difficult one, right?
Okay, so maybe what we're saying is, Chandra, if you can, you could maybe evaluate how hard it is for you to store the alarms on the device and make that difference, computational difference, and come back to us with an evaluation. Can you do that?
Yeah, sure. I will come back with the analysis.
Thanks.
So I think effectively what we're saying is that you need to do a rescan of all the open alarms on boot up of the device.
Yep.
So I have another call, so I need to just drop off.
Okay, let's reassess maybe sooner than in 2 weeks. I'll see if I can schedule a meeting next week at the same time. Okay.
Yeah.
Okay.
Sure.
Thanks, everybody. Have a great day. Cheers.
Yeah. Thank you.
Bye-bye.
Bye.
Bye-bye.
Bye.